A local maximum on a function and a local minimum on a function are also sometimes considered relative maximums and relative minimums. And by definition, we see that a local maximum will occur at a domain element C if its y value is bigger than all of the other y values, essentially in a small neighborhood around C. And so what that looks like is that if we have an ordered pair, C is the x-coordinate, F evaluated at C is the y-coordinate, we would say that the y-coordinate is the maximum value, and that maximum value occurs at the domain element C. Similarly, we would say that a function attains a minimum value at the domain element C if its y value is smaller than all of the other y values in a small neighborhood near C. So on the graph, what that's going to look like is that we have an ordered pair where C is the x-coordinate and the function evaluated at C is the corresponding y value. The minimum would be that y value, and we would say that that minimum occurs at the domain element C. Let's look at a quick example here. First of all, we're going to find the local maximums, and then secondly, we're going to determine where those local maximums occur. Now remember, anytime we're asked the question where something happens, that question will be answered with an x value or an x interval. In this case, an x value is what's more appropriate. So let's begin by first identifying the local maximums. And for local maximums, we're simply looking at these peaks. We have two maximum values here. We have two mountaintops. And now the question is, what is the maximum? Remember, the maximum is going to be determined by simply looking at the y value. The y values are the local maximum values. So we'll say that we have a maximum value of 6 and a maximum value of 10. Now, in order to say where these maximums occur, that's where we're going to use an x value. We say that this maximum value occurs at the x value -2. So we'll say that 6, the maximum value, occurs at the x value -2, and 10, the other maximum value, occurs at the x value 2. And now for part C and D, we're going to do the same thing but for the minimums. And for minimums, we're looking at valleys. We see we have several valleys occurring, several dips occurring on the graph. When we're asked to find the local minimum, the minimum is the smallest y value of each of these ordered pairs. The low y value is the minimum. And then for part D, when we're asked to find where do those minimums occur, that question is answered with an x-coordinate. This minimum occurs at x is equal to -8. This minimum occurs at x is equal to 0, and this minimum occurs at x is equal to 5. So let's formalize that down here and say that we have 3 minimum points. However, we only have 2 minimum values. -4 is one of the minimum y values, and the other minimum y value occurs 2 times. The y value 0 is the minimum both here and here. And so we'll say now where do those minimums occur? -4, the minimum, occurs at the x value -8, and the other minimum of 0, that occurs at 2 different x values. So we'll say 0 occurs at x is equal to 0 and x is equal to 5. Now we have a few more questions to answer. Part E says, how many times does the line y is equal to 3 intersect the function? So if we go back up to our graph here, y is equal to 3 is a horizontal line that's going to pass through the y value 3. And since the scale in the direction of y is 2 units, this is 2, 4, 6, 8, 10, the line y is equal to 3 is situated right about here. So how many times does this line intersect the graph? It intersects it once, twice, 3 times, 4 times, 5 times. This is considered an intersection point out here as well. So we'll say the answer to part E is going to be that the graph intersects y is equal to 3 5 times. And now we're asked about where the function is increasing and decreasing. Remember, when we answer these where questions, we're answering with, in this case, it's going to be an x interval over which this function is increasing and an x interval over which the function is decreasing. So when we come back up to our graph, remember we're going to pass through the domain from left to right to determine where it's increasing or decreasing. The graph is decreasing down to this ordered pair here. It's then increasing on this interval, decreasing here, increasing here, decreasing here, and then increasing here. So now we have to identify the intervals over which it's increasing and decreasing. The x interval over which we're decreasing starts at the x value, -10, and my function is decreasing over the interval from -10 to -8. And then starting at -8, it's going to increase all the way past the x-axis to the x value, -2. So the function is increasing here in this interval. It then turns and begins to decrease again, starting at the x value -2, and it decreases to the x value 0, and then it takes a turn, starting at x is equal to 0 to x is equal to 2, it's going to be increasing again. From x is equal to 2 to x is equal to 5, it's decreasing, and from x is equal to 5 to x is equal to 7, it is increasing. So now let's state our answers. We started at -10, and from x is equal to -10 to x is equal to -8, it was decreasing. And then it took a turn, and from -8 to -2, it was increasing. And then it takes a turn again and begins to decrease. So from -2 to x is equal to 0, it's decreasing again. So from -2 to 0. And then it takes another turn and starts to increase, starting at x is equal to 0, and it increases to x is equal to 2. We're increasing on this interval. And then at x is equal to 2, it takes a turn and starts to decrease again, and it's decreasing from x is equal to 2 to x is equal to 5, and then it increases from x is equal to 5 to x is equal to 7. So decreasing from x is equal to 2 to x is equal to 5, and then increasing again from x is equal to 5 to x is equal to 7. Now for these increasing, decreasing intervals, we are going to use closed brackets for all of these intervals, and of course interval notation to describe where that function is increasing and decreasing. And the last question says to determine the value of f at 2. F at 2 is going to be a y value, or the y coordinate of the ordered pair, where the x coordinate is equal to 0. So we go back up to our graph, and in order to determine the function evaluated at 2, we're looking for the ordered pair who has an x coordinate of 2. And the y coordinate that completes that ordered pair is that function value. So the function evaluated at 2 is just that y coordinate. So down here we'll just say f at 2 is equal to 10.